Okay, let's get back to the class. Okay, at the end of last hour, we talk about the way that we can do PCA in R, right? Now PCA is actually procedure-wise is actually a lot easier than clustering, right? You simply choose the variable that you want to do the reduction. Remember that PCA is a type of dimension reduction. And each variable will map to a dimension, right? Okay? So if we want to visualize 6 variables at a time, and every variable mapped to a dimension, it will become a 6-dimensional space. It's hard to imagine and hard to visualize, isn't it? Right? So PCA would actually reduce this 6-dimensional space into a 2-dimensional space. Okay, and in this 2-dimensional space, every variable has its own direction, and every subject has its own coordinate. Okay, coordination. And then so we can tell that the store who buy more dedication is here, right? In this direction, you can see the arrow. You can treat the arrow as a scale, right? So in this direction, the point who buy the most dedication is like 1A4, right? 40A, 1A2, 24, right? Okay? So you can see that if they are point here, it means that they are buying more of these two things. If the point are here, they are buying more of delicatessen. If point are here, they are buying more grocery, milk, and detergent. Okay? So in this way, you actually can project a high-dimensional space into a 2-dimensional plot. Okay? All right? So the idea of dimension reduction is kind of like I used to use this example, right? If you have a watermelon, right? Watermelon is kind of like a 3D object, right? So you have the seed inside this watermelon, okay? And the seed is actually the data point, okay? Within that 3-dimensional space, right? So now for some reason you can only display that watermelon, the position, the relative position of the watermelon seed in a 2-dimensional space, right? So you can squeeze the watermelon into a pipe, into a 2-dimensional space, isn't it? Right? So when you squeeze it, some information is lost, right? There is a cost for doing dimension reduction. You will lose information. Okay. The amount of information lost depends on 2 things. Okay. The first thing is that if the original variable they have high correlation. By correlation, I means if the 2 variables always vary on the same direction at the same scale, right? If that is the case, then like the information in these two variables can be like consolidated, isn't it? Right? So if the original variable has high correlation among them, right? The information loss is smaller, right? It can retain more information after correlation, after dimension reduction. And the second case is that the watermelon, back to the watermelon example, the direction of compression is important, right? Right. If I choose the right direction, I can reduce smaller. I can reduce it into two-dimensional and still maintain the relative position of the seat, right? If I can reduce it into a lower dimension and still retain most of the relative position of the watermelon seat, that is a good compression, isn't it? Right? So this PCA algorithm is an algorithm that try to find a way to compress, right? So that after the compression, the amounts of information retained in the lower space, in the lower dimensional space, is maximal, right? Okay, and in this case, it can retain 44% in dimension 1, and it can retain 27% in dimension 2. So as a total, it retain about 70%, right? So in this two-dimensional space, it actually retain about 70% of all of the information in that higher dimension, 6-dimensional space. Okay? So the higher this percentage is, the better the PCA result. Okay? But that actually depends on the data, right? Okay? If all of the variables are not correlated to each other, then you will see that the result of PCA, I mean the information retained, will be poor, right? Okay. Now, a good PCA should have about at least 50% of information retained, right, in the lower dimensional space. Otherwise, you'll lose too many dimension and too many information, and that PCA is not trustworthy. I should say so. Okay. So now, after that PCA, I told you, right? The PCA has a default plot, but that plot is actually very ugly, right? Very difficult to use because they plot the point and the variable in two different plots. The way we want to plot is like plot it into a biplot, which means that the variable and the point are plot together, right? So that I can tell, right? So I can tell which point is I can compare all of the points and all of the variable in one plot, right? This is the way of biplot. But the default biplot is still not very it's not very good, okay? So all of these things is just to make it like looks better, okay? It's just to make it look better. Now, let me go back to here so it's easier. Now, see, W is the data frame, right? Okay. So if I want to if I want to group the individual, if I want to plot this with the result of our clustering variable, right? This group is actually created by our hierarchical clustering, right? Okay. So I can do that, and if I do this, then every color represents a group, right? Every color represents a group, isn't it? Okay. And if I want to, if I do this, I can see that the as you can see that this is one group, and the size is actually like, right? I mean the the difference between the group is smaller, and the difference across the group is actually larger, right? So I can say that the all of the 440 retailers, there is one group that buying the character of this group is they, because they are in the opposite direction of here, right? So this group, they actually buy very their variable of milk, grocery, and detergent are small, right? Okay, because in this direction, it means that milk, grocery, and detergent are larger. Okay, so we have three group. They are buying more milk, grocery, and detergent. This one, and this one. Okay, and this three group can be separated by the amounts of frozen and delications amount, right? This group has a higher, right, higher detergent, fresh and frozen, and this group has the smallest amount of these three things, okay? And then we have one group here, and we have one group here. So you can see the group characteristic directly. You can read the group characteristic directly from the plot, right? Okay, okay. During the break, some classmates come to me and saying that actually, if you want to like plot it with the channel, you can do that. Okay. So because this is control the color, right? So now you can see the difference between the channel, right? So you can see that channel 2 tend to buy more milk, grocery, and detergent. And channel 1 actually tend to buy less. You can see that, right? If I divide it by region, what will happen? Well, as you can see that region 1, region 2, and region 3, they actually do not have very systematic difference between them, right? Except that the region 3, they have a wider, right? They are distributed wider, right? Okay? So together by clustering and dimension reduction, it helps you to uncover the hidden group, okay, amongst the subject. This group are actually not hidden. This group, I mean region and channel, they are observable, right? You have some observable group already. For example, in the Tafang data set, you have the age group, you have the area code, right? They are observable. But when you plot the observable group in a space, they might not have distinctive characteristic, right? You get my point? You can use the observable group, right? And sometimes the observable group already have some different characteristic. For example, like if you plot channel, you can see the difference between two channels. Okay, that's good. Okay, and some observable grouping, like sorry, you cannot tell the difference very well, right? Okay, and that's why you want to use clustering analysis, right? When you use clustering analysis, you try to like pull the, you try to group your subject in a way that they are distinctive to each other, right? So let's get it back. So by doing that, it's not perfect, but actually this is what we can do, right? This is what we can do. Okay. The best way, I mean statistically, this is what we can do best on separating the subject into groups. Okay, so you can see you can tell their characteristic very clearly when you do that in the PCA space, isn't it? That's why clustering and dimension reduction usually were used together. Okay, and their purpose is to help you to find the hidden relationship between the variable and between the subjects. Okay, so this is important, so I say it again, right? The reason that you are using clustering and dimension reduction is try to like find out the hidden grouping, right? If the grouping is already there, then you don't need to do clustering, right? Like region, like edge group, like area code. It's already there, right? But sometimes you want to group subject by their similar behavior, right? And that's why you do the clustering, okay? And sometimes you want to observe many variables in one space. You want to compress a high dimensional information into a lower dimensional for better observation. Then you are using dimension reduction, okay? That's the two technique that we are teaching today, okay? Let's see more case, okay? Then you have a better understanding of what how they would use, okay? I do not have time to like explain these things, but you can try it by yourself, right? It's just like a GG plot. You have a lot of options to use if you want to have a better looks, right? You can like try them by yourself. Now let's get into our second notebook. Now the second notebook is actually more interesting than the first one. The first one, basically, I use it to explain the concept of PCA, the concept of clustering, right? And using tool. Now let's talk about application, okay? Okay? We already covered the basic concept and the tool for dimension reduction and clustering. Now let's talk about their application. Okay. Maybe the most important application of clustering is customer segmentation. Does anyone know what is customer segmentation or market segmentation? Anyone who can explain this for me? You should have done this already, right? You learn marketing, right?
Separate the customer to different group and choose one of the group to target.
Right, segmentation is separate them, right? And choosing one is targeting, right? How to approach them is called positioning, right? This is the three things, right? STP, right? And they are the basics of marketing, right? First of all, you separate your customer into similar groups, right? That's the key word, right? And then you choose some of the segment that you want to focus on, right? And then depends on their characteristic, you want to design your campaign, you want to design your product so you can convert them, you can influence them, right? That's the three things of STP. So segmentation is just the first thing. It's not the second, the third. Okay? So in the defunct in the Tafong case, clustering can only help you to do the segmentation. It cannot help you choose the focus, right? It cannot help you design the campaign, right? So how do you do that? Okay, it can help you to do the segmentation, but how about targeting and positioning? Any idea? So how do you want to do your do your midterm report? If you only can do segmentation, then but for a complete marketing strategy, you need to cover STP, right? So you only have segmentation, then how can you do targeting and positioning?
Then we have to find, for example, like we have to find the exact maybe thing that
You need to look into the characteristic of the segment, right? Segmentation can not only help you to separate them, it can also tell you the characteristic, the distinction between the group, among the groups. So that looking into the groups, right? Okay, and you need to determine them by yourself, right? Depends on their distinctive characteristic, depends on their importance to you. Okay. So how can you determine the importance of a customer group for you? What is the indicator that you can use to judge the importance of a customer group?
The frequency and the total money they spend.
Right. So these things are like their revenue contribution, their margin, right? Their profit contribution, the frequency they buy, the average amount they both from us. So these things actually you have to use your domain knowledge, right? And combine it with the result of the analysis to make strategic suggestion. Okay? So it's not only uh, like it's not only the it's not only the analysis, but also your domain knowledge. Okay. Okay, let's move on. Now, airline. Let's look in the data first. Okay. Sorry. Yeah. Thank you. Get some water for me. Thank you. It does. Okay. Reading the data, and the data has these variables. Okay. Let me actually do that. Let's see. Have I? Okay, so this is the data. We have 4,000 customers, and these are actually the members. Okay, so you know the loyalty program of airlines, right? Okay, you fly, right? So you You know, this is kind of like the member of the loyalty program of airline. Okay, so so very naturally, every record is represents what? This is the loyalty program data, right? So looking into the data, this is the balance, mileage, something. So every record is what? It should be very easy to guess, isn't it? Because they are loyalty program data, right? So loyalty data program is what we call CRM, right? Customer relation management, right? So every record is one. Yeah, it's one customer, right? Okay, like this. So every role is now our unit of analysis is customer, and the column is the attribute of the customer, right? Okay, so let's see how many columns do we have. So this is the column that we have. Uh, Balance is the regular mileage remaining, and I don't know what is high class mileage, but they count like two type of mileage. Okay, regular mileage and high class mileage. So supposedly the high class mileage is better, is superior than the regular. And now these are the two field. This is called bonus mile and bonus transaction. It means that in the past 12 months, the number of non-flight transaction. Okay, what it means by non-flight transaction is you earn the mileage that you earn is not necessarily come from flight, right? Sometimes you rent a car, you get the mileage, right? Sometimes you go to a hotel. Yeah, they have some alliance, right? So you go to the alliance car renting company or go to the aligned hotel chain, you will earn mileage, right? Sometimes you can buy mileage, right? they are website you can actually buy some mileage if you want to, like. So this what we means by non-flight transaction, right? The number of time you acquire this non-fly mileage, this is the bonus transaction, and the number of mile you get from this non-fly transaction is this variable, okay? And these two variables is easier, right? The number of fly in the last 12 months, and this is the mile, right? This is the number of fly, and this is the mile that you earn in the past 12 months. Okay, and this is the days things enrolled. Okay, is it clear? Okay, so data is clear. It's very typical CRM data, right? 4,000 customer, right? Now now we want to do a clustering, right? And as I told you that standardization, we already explained this already, right? If you look into this original scale, right? The number of transaction is within 0 and 86, right? And the balance the balance is like between 0 and like this is like 1.7 million, right? As you see that, right? So if we use this original scale, and I do the distance matrix, all of the distance is dominated by this variable, right? The other variable will like disappear, isn't it? Okay, so that's why we want to standardize, right? We do standardization, and we scale A and put it into AN, which means that this is standardized, normalized data frame. Okay, and then we can do a distance metric, right? we do distance measuring out of the standardized data frame, isn't it? Okay. The method you can specify, but if you do not specify, the default is already Euclidean. Okay. In hierarchical clustering, you can also specify the method, but I mean, usually you don't need to specify method at all, right? You can like just we have done in the last hour, right? You can just write in pipeline and do standardization, distance, and also hierarchical clustering in one line of code. Okay. Now here is the dendrogram. Okay, here is the dendrogram. Then looking into this dendrogram, you can like cut it into like 1, 2, 3, 4, 5 group, or you can cut it into, I think 5 or 6 group is like good choice, right? See, it's always a question, you know. How many group to divide is always a question, but there is no, see, clustering is you don't really have a optimized number of clustering, right? All I can tell you is like you do try and error, right? I mean, some people will tell you some criteria to determine the number of cluster, but mostly in clustering you are doing try and error. Okay. I will show you later after we finish this after we finish this example. Okay, I'll show you what is the criteria for a good number of clustering. Now, for now, let's say that we want to like do 5 cluster. Okay, so we can actually cut them into 5, right? Just do this, right? This is the result of HC, and I cut it into 5 group. Then I will have a clustering vector, right? Okay, and this clustering vector, the length of this clustering vector is how long? What is the length of this cluster vector? Anyone? We can send out a gift, right? We do not have, we have not sent gift yet, right? How long? It is a vector, right? After cut tree, you will produce a vector, right? And the length of the vector is determined by what? You are separating the customer into 5 group, right? So each customer will be assigned into a group, right? So if you want to assign each of the customer into a group, the vector has to of length. How many? Sorry? Telegram? kg? kg is the name of the vector, right? I'm asking what is the length of the vector?
You mean length?
Length, the length, right? 5? 5 is the number of distinct group. And this kg has to assign a group into each of the customer, right? And how many customers do we have? 4,000, right? So in order to assign this 4,000 customer, each of them into a group, this vector had to of length 4,000, right? Okay, so this vector is of the same length as the data, right? As the data. So if I do a table, then I can see the group size, right? Okay, so I see the group size this way, right? Okay, and then after I know the group size, I want to know the characteristic of each of this cluster, right? Okay, so I can do a column mean to each of the group. So you can see that this is the first, this is the average balance of the first group. So you can see that if I want to see balance, then the group that has the largest average balance is actually group 3, right? The group that has the smallest balance, average balance is like group 5, okay? I can also compare the average number of transactions, right? The average number of flight, right? Right? This is the number of flight in the past 12 months, isn't it? Right? So when I do this, I can see that this group fly a lot, isn't it? Okay? Right. So because this is the original data, so the scale is the original scale, right? So make it easier to read the table. This is the original scale. But if we want to plot it into if we want to visualize this, it's very difficult, isn't it? Right? Because the things that every variable has different scale. I cannot like, if I want to draw them into a like bar plot, I will have a big problem, right? So actually, if I want to draw things like this, okay, if I use the normalized data instead of the original scale, right? Okay, because it's normalized, so 0 is actually the average, the population average, right? Okay, and whatever is going up means that this is 5 group, right? 1, 2, 3, 4, 5, isn't it? So if I like take the group average of all of this variable, okay, this is simply to take the group average of the 5 group. Then I make a bar plot, okay. So you can very clearly see that this group is like everything is going downward except days things in row, okay. So what is this group? Can you name this group? I mean, you can see the characteristic, right? I mean, because they are standardized, right? So 0 is the population average, okay? And this group is actually, everything is lower than average, right? Except days things in row, okay? So what is this group?
Economy.
Sorry?
Economy group. Like economy group. Like
Equal the mean group?
economy. Like a sheep.
Economy?
Yeah, economy.
Is that so? The economic group, they can also fly a lot, right? They just don't want to buy a, but they don't, right? As you can see that if they fly a lot, they should have these things above average. But this thing only have one thing. It's very significantly different from the other. It's their day things in row. So this group of people. How many of them? We have 776 member. Everything is going downward, means that they barely have any activity, right? Right. So they are like inactive for a long time, right? Because they enroll for a long time, right? So this group of people are inactive for a long time, right? Isn't it? Okay. So are they very variable for us? I mean, So in what way? They are our member for a long time, but recently, in the past 12 months, they barely have any activity. So
But we can contact them, like send it
right.
email or
Usually we will call this type of customer called sleeping customer. They like fall into sleep, right? You want to wake them up, right? Okay. If you don't, right, they would possibly leave you forever, right? Okay. So now, looking into their characteristic, you will have some strategy to deal with them, right? To improve their performance, right? Okay. See, so this is how clustering can help us in a real case. Okay? You see that? Right? It helps us to like separate into distinctive groups. Okay? And then see, let's take another look at group 5, right? What is the characteristic of group 5? How is it different from this one? They are like everything is going down, right? Right. And especially these two things are like very, very low.
new customer,
Sorry?
like very new customer.
Yeah, they are new customer. That is one thing, right? Okay. And this customer, they do not use the bonus, right? So they only fly, okay? They fly from us. Most of their mileage earned from their actually fly, right? So this the new customer that we acquire maybe within a year. You see that? And they earn their mileage from actually fly, right? Now you compare this group with this group, okay? In this group, they're actually newer than this one, right? Because they are, right? But their mileage earned from bonus, right? So most likely these are not the members that we acquire during our flight. These are the new members that acquire from our alliance partner, right?
They use it.
Right. So by looking into this characteristic, you can tell, right? You can tell the difference from group to group, right? This is a good customer. This is a good clustering, right? A good clustering is that the result of clustering by looking into the characteristic, okay? You can name them, right? It's good to communicate. It's good to operate, right? Make it easier to communicate, easier to operate, right? And easier to recognize, easier to name them, right? If you look into the characteristic, you cannot even name them, then that clustering is have no use to you at all, right? Isn't it? Right? So when we are doing clustering, usually I tell you that in order to determine the number of groups, basically you will do try and error, right? you try it, right? Now after you acquire this clustering vector, you do not know the quality of clustering yet. Okay. You need to like use this clustering vector to acquire this group characteristics, right? So the quality of clustering depends on the quality of group characteristics. Okay. Now this is very important. Let me say it like 2 times. Okay. The quality of clustering depending on how distinctive, how meaningful the group characteristic is for you. Right? I say it 3 times because it's very important. the quality of clustering, like it depends on how distinctive, how impactful, right? How meaningful the group characteristics are distinctive from each other. Okay? You get my point? Okay. And clustering is free, right? I mean, you can group it like 10 group, and you can group it like 20 group. You can group them by 50 group, right? The problem is when you group it by too many groups, you cannot manage them, right? Because they are too small, right? It might not be worthwhile to like design a strategy for them, right? Okay, so on the one end, you actually want to have specific grouping. On the other end, you cannot afford to have too many groups, isn't that right? And in between them, you will determine the grouping. There's no optimum number of grouping, right? There's no such thing, okay? No such thing. You do the grouping. Actually, you don't really need to be able to operate on all of them, right? We do segmentation, targeting, right? When you do targeting, you actually only act on maybe 1 or 2 of the group. Okay, so when I say that the characteristic must be distinctive, must be meaningful to you, I don't mean that every group they need to have this characteristic. No, right? If you can like identify 1, 2, or 3 groups that you can operate, okay. If only that you can identify a few groups that is like good to communicate, good to access, good to operate, right? That is a good clustering already, okay? So you get my point? Now in the Tafang, we are running out of time, okay? So in the Tafang cases, well, maybe you don't want to use clustering, right? You can simply use the observable category like age, like area, to separate your group, to choose your group, okay? Or you can use like customers RFM, that type of things, to group them, right? When you use RFM, you have 2 choices. One choice is you can set some rule, right? For example, do some chop the RFM into like 4 quarters, right? And you only target on like some combination of RFM, right? That is another type of choosing your customer, choosing your focus. Okay, and the other way of choosing focus is to use this, right? You can use statistic method, use some variable to do clustering, but not necessarily you need to use this. But this is one of the methods that help you do the customer segmentation. And segmentation is the first thing in marketing, right? STP and then 4P, right? So, so this is the first thing in marketing. Besides the existing observable grouping variable, you can use this way to find some other segmentation method, right? See, actually, if you ever have a chance to take a marketing job, okay? If you ever have a chance to enter a company that do marketing, and you do marketing, most of the time you are doing segmentation, right? You are segmenting, you are doing the segmentation in many different ways, okay? Because every week, every season you are launching different type of campaign to address different type of customer, right? Isn't it? So you will use different grouping variable. You will group your customer in different way and address them in different way, right? That's what marketing do for living, okay? So today we can only go to this point. I think so. Next week, like try to make a midterm report, right? That use we have learned so far, okay? And then next week we will like maybe finish the dimension reduction. Maybe we can spare some time so that each group can maybe have like 10 minutes to present your works. How about that? Okay?
Can we be
Sorry?
one more week?
Sorry?
Can we have one more week?
Do you want to have one more week? Okay. Okay, so we have one more week. Okay. It will be easier because today you just learn clustering and you have not have the experience on dimension reduction yet. You will need that, okay, for a complete cycle of data exploration. Besides data processing, visualization, you would definitely need clustering and dimension reduction. Okay, so next week we will finish dimension reduction, and then you will have more time to do that, right? Stay together, right? So so you can make the most out of the class. So this week we do not have more group assignment. Just still like keep doing your midterms, okay? And the week after, let me see. So it would be like December the 6th, okay? That you will present your is that midterm? It's already the third quarter already. Okay. But as I say, this is the first time that I ever deliver these things in the IB department. So I will adjust, okay? So that's fine. I think we can still catch up. Okay. That's I'll try to deliver whatever is most important by the end of the semester. Okay. Okay, so that's for this week. Any more question? If no more question, that's I'll see you next week. Okay. And we continue on doing this dimensional reduction, and maybe I will like teach you some more techniques that you can use for your midterm. Okay. Okay. So class dismissed.